So if you were given two linear equations and asked to graph them, what would your graph look like? Well, all right, let's make this simpler. Start off with what does one linear equation look like? Oh, okay, so I have an equation, it's the equation of a line, and it's a graph of one line. Okay, so if I have two linear equations and asked to graph them, what would the graph look like? It must be two lines. All right, okay, so it's going to look like two lines. So now, if you were asked to solve that system of equations, what would you be finding on the graph? Well, let's see. On each of those, solving means I'm trying to find what x equals or what y equals. They have both of them in these equations. That makes it a little confusing. Let's see, along any one line, there's an infinite number of x's and y's that are true on that line. There's a combination of x and a combination of x and y on this line. And there's also a combination of x and y that are true for many places on the other line. So what would it mean to solve that system of equations? Well, wait. Maybe I'm trying to find the values of x and y that make it true for both equations at the same time. Well, that's easy then. It must be where they intersect. The only place where the x and y values are the same for both of them is right where they intersect. So that's what I need to solve and find the x value and the y value that actually of where they intersect, which is the only place where they have a point in common. So now I want to solve this system y equals x minus 3 and y equals minus 2x minus 6 by graphing. All right, so basically what I have to do is graph those two lines and find out where they intersect. So let's do that. So I graphed the line y equals x minus 3, and I started off at the y-intercept of negative 3, and my slope here it's just an x, so it means it's 1x, or a slope of 1 over 1. Which means I rise one and then go right one, rise one, go right one, rise one, go right one. I keep continuing that pattern all the way up until I get to the edge of the graph. I can also go down one, left one, down one, left one, down one, left one. I continue all the points and then connect the dots. All right, and then I do the same thing for this other graph, which is equation y equals minus 2x minus 6. I start off with a y-intercept of minus 6. And the slope is negative 2 or negative 2 over 1, which means I rise negative 2, which means I go down 2, and I run 1, which means 1 to the right. Down 2, right 1, down 2, right 1. Now I've run out of room on this graph, so now I'm going to go the other way. And just like I can go down 2, right 1, I can also go up 2, left 1, up 2, left 1. And I continue those points all the way to the edge of the graph. Connect the dots. All right, now I have a system of two equations. This line here has an infinite number of points on it. This line has an infinite number of points on it, but there's only one point that they have in common. So if I'm trying to solve this system, I want the one point that they have in common, which is right here. This is their point of intersection, and the answer is x is equal to, in this case, negative 1. It's 1 to the left of the y-axis, and it's also 4 down, so y is equal to negative 4. That is my solution to this system. Now let's go ahead and try this on number 3. Let's go ahead and graph this equation, y equals x minus 3, and graph this equation, y minus x equals negative 3, and graph them and see what we get. Keep in mind that for the second equation, it's not solved for y. So if you want to use the cheating method of slope-intercept form, make sure you solve for y first. So I solved this equation, the second equation, y minus x equals negative 3. I solved it for y. I added x to both sides, which gave me y equals to a positive x minus 3. All right, and wait a second, that is the exact same equation as I had in the first one. So I graphed it, and I said, okay, I've got one line that's right here, and I have another line that's the exact same one on top of it. So what solution do they have in common? Where do they have the same x and y? Well, anywhere on that line. In fact, there's an infinite number of solutions. So let's put that down as our answer. Infinite solutions. Okay, let's go ahead and graph the next one. All right, this time we have two equations here, and we're going to go ahead and graph them and then see where they intersect. So this time I found that these two lines had a different y-intercept, but they had the same slope, which means they are parallel lines. So wait a second, how do I find their solution? Where do they have an x and y in common? Where do they intersect? They never do. So this one has no solution. Now I'm going to go ahead and solve this system. I've got one equation, y equals 2x minus 3. I'm going to graph that, and I'm going to graph the equation y equals to minus 1, and let's find out where they intersect. So I graphed y equals 2x minus 3, a y-intercept of minus 3, and a slope of 2, which is up 2, right 1, up 2, right 1, connect all the points. Some of you might have had trouble with graphing y equals minus 1, but actually this is an even simpler graph. This has a y-intercept of negative 1 right here, and a slope of 0, which means it is a horizontal line. Another way of thinking about it is the fact that it's y equals minus 1. Where in the graph does y equals minus 1? Well, here, and here, and here, and here, and here, all the way along that line is where y equals to minus 1. All right, so now I need to solve it, find their intersection. Well, that is x equals to 1, and y equals to negative 1. Interesting enough that in the equation, one of the solutions was already given. So we just had to find the other one, x equals 1 and y equals to negative 1. Okay, so the fact that we already know one solution in this one is interesting because we can use that. We don't have to use graphing to be able to solve this equation. We actually, in this case here, I want to solve this by substitution, and that means if I know what y is already, y is equal to minus 1. In fact, I go to write my answer, I'm going to put x equals and y equals to minus 1. I'm going to put that, I'm going to start off with the answer because a lot of my students forget to put in the answer the one that's already given. All right, so I start off writing that. All I need to do is find the x value of this. So I use substitution. I take my y equals minus 1, and I'm going to substitute it into the other equation in for y. If y is minus 1, then I can just put a minus 1 in for y. All right, so now I have this in my equation. I can solve this for x now. Add 3 to both sides since this is subtracting 3. And now I have 2 equals to 2x. Since x is being multiplied by 2, I now divide by 2. And I get 1 equals to x, or x equals to 1. And I just found the other answer. And it certainly matches the previous one. All right, so let's go ahead and have you go ahead and try to solve this system down here, y equals x minus 4 and y equals 7 by substitution, and let's see if you get the same thing that I do. So the first thing I did is make a place for my answer, x equals and y equals 7, well, I already know that. I substitute the 7 in for y, solve for x, and I get x equals to 11. I put that in my solution, and there's my answer. Okay, now let's go ahead and do 8 and 9. And see if compare your answers to what I have. So this time they gave me the x value, so I wrote in right away x equals 2, y equals something, I don't know what that is yet. But this time because they gave me x equals 2, I need to substitute that 2 in for the x, not for the y. So actually this is easier. 3 times 2 is 6 plus 4 is 10, y is equal to 10. There is my answer. Okay? This one I'm substituting the 1 in for the y. I solve that equation then for x, and I get x equals to minus 4. There's my two answers.